Okay, Assalamualaikum and have a good day, everyone. So, we are still in chapter 4, Industrial Robotics. And for today, we will move to the last part of chapter 4, which is part 3. So, if you still remember, in part 2, we have learned about body and arm parts. Okay, so for part 3, we will cover another parts in the robot manipulator, which are the wrist and end effector. Okay, so in robot, wrist is used to orient and effector. So remember, there are two sections of a robot arm or manipulator. So the first section is this part known as body and arm assembly, and the second section is the wrist assembly. So wrist assembly is attached to end of arm, and an effector is attached to end of wrist assembly. So this is the wrist and this is the end effector. 3 degree of freedom robot wrist refers to three axes the wrist can perform, which are roll, pinch, and yaw. So roll movement is also known as x-axis. Pitch movement is also known as y-axis, and yaw movement is refers to z-axis. So wrist has 3 degree of freedom: roll, pitch, and yaw. X, Y, and Z axis. So figure shows an example of 3 degree of freedom robot wrist. Okay, so 3 degree of freedom means the wrist in the figure has 3 numbers of independent movement. This is the first independent movement. So this is the second independent movement, and this is the third independent movement. Since the wrist involved with type R, and type T joint, therefore the joint notation for the wrist is semicolon RRT. So remember, this is the first section and this is the second section. So since the wrist involved only in the second section, meaning that the joint notation is only R, R, and T. Figure in the slide illustrates all these role, pitch, and yaw of robot wrist. So roll refer to x-axis, pitch refer to y-axis, and yaw refer to z-axis. Okay, as mentioned just now, an effector is attached to end of wrist assembly. So an effector is attached to uh, end of wrist assembly. So in manipulator, end effector is known as special tooling for a robot that enables it to perform a specific task. Basically, there are two types of end effector commonly used in manipulator, which are gripper and tool. Gripper is used when the task or operation requires work such as grasping and manipulating object. Meanwhile, tool is used when the task or operation require work such as to perform a process such as cutting, screwing, drilling, welding, and spraying. So figure at the left shows an effector with gripper. So this is the gripper attached at the end of an effector. So this is the gripper, and the right figure here shows an effector with tool. So in this case, the tool is the spraying tool. Okay, if you still remember in robot joints topics, okay, each of robot joint is driven either by using electric, hydraulic, or pneumatic. So, for example, figure in the slide shows robot driven by pneumatic piston. Okay, so there are three types of drive for robot: electric, hydraulic, and pneumatic. This slide illustrates the overall view of a manufacturing plant. As you can see in the figure, the robot manipulator is used in the plant to facilitate operations. Uh, Now, who's control the robot? Who's control the robot? So the robot is actually controlled by the robot controller. The robot is controlled by the robot controller. And microprocessor-based controller are commonly used in robotic system today. So figure shows a control structure of a robot microcomputer controller. Okay, so robot control system can be categorized into four, which are limited sequence control, playback with point-to-point control, playback with continuous part control, and intelligent control. Okay, so limited sequence control is the most elementary control type. This type of robot control system is always used for simple operations such as for pick and place operations. So normally this type of control system use mechanical stops to set position. So the point-to-point control is capable of moving from one point to another point. So this type of control system is more sophisticated compared to limited sequence control. Okay, and the controller records work cycle as a sequence of points and then play back the sequence during program execution. So this control system is normally used for spot welding and hole drilling. Okay, next we have playback with continuous part control system. Okay, and compared to the playback with point-to-point control, so this continuous part control has greater memory capacity, and this type of control system is also said has the capability to compute path between starting and end point. So spray painting, as illustrates in the video, so spray painting is one of the application for this type of control system. Okay, now the last control system to be covered is intelligent control system. So robot with intelligent control can exhibit behavior that make it seems intelligent and similar to human. So robot with intelligent control can respond to sensor input, interact with environment, make decision, communicate with human, make computation, and etc. Okay, so here are several reasons for the substitution of robots in replacing human labor in industrial work. Okay, so a robot is preferable to be used when the work environment is unsafe, unhelpful, hazardous, uncomfortable for human. So a robot is usually capable of performing the work cycle with greater consistency and repeatability than a human worker, especially when the sequence of elements in the cycle is the same and the elements consist of relatively simple motions. Okay, so all these are detailed description for the substitution of robot in replacing human labor in industrial work. So, well, I think that's all for chapter 4. Thank you for watching and bye.